In this class, we are going to study how to determine moment of force using vector approach. Okay. Now, let's consider first scalar approach. Consider an arbitrary body of arbitrary shape. Let force F be acting on it. Let O be our moment center. Let D be the perpendicular distance from the line of action of force to the moment center. So, according to scalar approach, we can write moment of force equal to force into perpendicular distance. Now, let's consider vector approach. In order to apply vector approach, we need to define a position vector R bar. Position vector R bar. Okay. Let R bar be the position vector, and position vector is running from moment center O to a point on the line of action of the force F, that is at point A. So, according to vector approach, we can write moment as R cross F. We can write a position vector like this. Let the position vector R bar be x into I plus y into j plus z into k, and let force be F bar equal to Fx into I plus Fy into j plus Fz into k. We can determine this R cross F by this formula, determinant ijk x, y, z, fx, fy, fz. This is how we can determine R cross F, and hence we can determine moment of force. A force of 60 kN passes from point A 023 to point B 705. Find the moment of this force about a point C 743. And now try to represent the given data pictorially. Okay, we have given a force F. A force F is given, whose value is given as 60 kN, which passes from a point A and B. So, 2 points are given. Let this be point A. Its coordinates are 0, 2, 3. And point B is given, whose coordinates are 7, 0, 5. Find the moment of this force about a point C. So, let this be our point C. Okay. Whose coordinates of point C are 7, 4, 3. We are going to determine moment of force about C. Okay. In order to determine moment of force, we need to know the position vector and force vector. Moment about C equal to position vector R cross force vector. Now, force vector equal to magnitude. Force magnitude into unit vector. We have to determine vector AB first. Vector AB equal to 7 minus 0 into I plus 0 minus 2 into j plus 5 minus 3 into k. Okay. Take the difference. Let this be S2, Y2, Z2. Let this be S1, Y1, Z1. Now, S2 minus S1 into I plus Y2 minus Y1 into j plus Z2 minus Z1 into k. We will be getting 7I minus 2j plus 2k. Unit vector along AB equal to 7I minus 2j plus 2k by root of 7 square minus 7 square plus minus 2 square is same as 2 square plus 2 square 0.93I minus 0.26j plus 0.26 K. So this is unit vector along AB. Now we can determine force vector from this formula, magnitude into unit vector along AB, that is equal to magnitude of force is 60 kN into unit vector along AB is 0.93I minus 0.26J plus 0.26K. 55.8 into I minus 15.26 into J plus 15.6 into K. So we have determined this value, force vector we have determined. Now we have to determine R bar. We can determine R bar either with respect to A or with respect to B. Both are correct. Okay. So let's determine R bar with respect to B. Okay. So what is R bar? R bar equal to S2 minus S1. Let's consider this as S2 and this one as S1. So S2 minus S1 is 7 minus 7, and that is 0I plus 0 minus 4J plus 5 minus 3K, which is equal to 0I minus 4J plus 2K. Moment of force about C equal to R cross F. Well, we have determined R here. We have determined force magnitude here. Substitute the values. Determine IJK. 0 minus 4, 2. And the force value is 55.8 minus 15.26. 15.26. So we will be getting a moment value as minus 31.2I plus 111.6J plus 223.2K. Okay. So we got moment of force about C as minus 31.2 into I plus 111.6J plus 223.2K. Okay, this is moment vector. We can determine magnitude of moment like this, out of 31.2 square plus 11.6 square plus 223.2 square. So answer is equal to 251.49 kilonewton meter. Couple. Two parallel force equal in magnitude and opposite in direction constitute a couple. Consider two forces, a vector F and a vector F, which is equal in magnitude but opposite in direction. Now let D be the distance between these two forces. Let O be our moment center. Okay. Let A be a point on the line of action of this particular force and B be a point on the line of action of this particular force. Okay. Now we are going to note down the position vector. Position vector from the moment center to the line of action of force F at B, RB, corresponding to point A, position vector B, RA. Okay. Now, what is moment of force? What is the moment of force F at point A about O. We have array, vector array into vector F. Moment of force F at B about O equal to position vector RB cross minus F. Since this force is opposite to this force, we are taking here minus. Now, what is the sum of the moments? Sum of the moments equal to sum of the moments of the above two force about O equal to vector RA minus vector RB cross F. What is vector RA minus vector RB? We can mark the opposing side of this triangle as vector R. So, vector RA minus vector RB equal to vector R cross F. So, this is the expression for moment of couple, which is same as moment of force. Now, let's do one more problem. Two forces F1 bar equal to 50I plus 80J plus 100K and force F2 bar equal to minus 50I minus 80J minus 100K F at point A 0.7, 1.51 and B 1, 0.9, minus 1 respectively. Calculate the moment of the forces and perpendicular distance between the forces. So, this is a vector problem. നിങ്ങൾക്ക് കിട്ടിക്കഴിഞ്ഞാൽ നിങ്ങൾ അതിന്റെ pictorial representation ഒന്ന് വരക്കുക. Okay. So, let this be our force vector, first force vector F1 bar, and let this be F2 bar. Okay. Why we mark F1 and F2 like this? നമുക്കറിയാം ഇവിടെ F1 തന്നിട്ടുള്ള എത്ര? F1 equal to 50I plus 80J plus 100K. F2 തന്നിട്ടുള്ള F2 ന്റെ വാല്യൂ നോക്കുകയാണെങ്കിൽ ഒരു മൈനസ് സൈൻ നിങ്ങൾക്ക് അതിന് പുറത്തേക്ക് എടുക്കാൻ പറ്റും. 50I minus of 50I plus 80J plus 100K എന്ന് പറയാൻ പറ്റും. ഓക്കെ, ഈ ഒരു വാല്യൂ കൺസിഡർ ചെയ്യുകയാണെങ്കിൽ. So F1 and F2 are equal in magnitude but opposite in direction. Another one, and this F1 is acting through a point A. Let this be that point A, and the coordinate of A is 0.7, 1.5 and 1. And F2 is passing through a point B, whose coordinate is given as, let this be that point B 1, 0.9, minus 1. Okay. Now what we have to determine? We have to calculate moment of force. So, we know if we can determine position vector between these two forces, let that position vector be R bar. Okay, we can calculate moment from the formula F equal to R cos F. Okay, now let's determine position vector R bar first. Okay, R bar equal to, let's consider this as S1, Y1, Z1 and this as S2, Y2, Z2. So R bar equal to 0.7 minus 1 into I plus 1.5 minus 0.9 into J plus 1 minus 1, that is 1 plus 1 into K, which is equal to minus 0.3 into I plus 0.6 into J plus K. So, what is moment? Moment equal to R cross F IJK minus 0.3, 0.6 to 50, 80. You will be getting moment as 100I plus 136 minus 54K. So what is magnitude of moment? Magnitude of moment equal root of 100 square plus 130 square plus 54 square. Whose value is 172.67. Okay. Now, what is the magnitude of force? Magnitude of force equal to root of 50 square plus 80 square plus 100 square, which is equal to 137.48. We know from scalar approach, moment of force equal to force into perpendicular distance. So we have got magnitude of moment and magnitude of force here. So perpendicular distance equal to magnitude of moment by magnitude of force, which is equal to 172.67 by 137.48, which is equal to 1.26